Hello everyone! In this video we'll cover the very basics of 2D vectors. I want to make a broader linear algebra, everything you ever want to know about vectors kind of series. But for now let's begin with some examples of what vectors can be. And in this case we're looking at 2D vectors. Okay, so 2D vectors are going to have essentially, they're just two numbers, which are real numbers in our case, or what we would call floats or doubles in computer science. And they're going to be my x and my y coordinates. We can think of the 2D vectors in two different ways. Well, there's many different ways to think about them. One of them is to think of them as points inside of a canvas. So this would be one point, this would be another point. What's really happening is that we have an origin in our canvas, our 0, 0 point, and we're thinking about the blue point as this distance from here to here, and the red point as this one here. So this would be like the x value, this would be the y value, and this would be the x value, this would be the y value. We'll be using the following, where this is x positive and this is y positive. This is because in computer science or in computer graphics, we usually want to think as the top left corner as our 0, 0 point, because it's a bit like a screen. A screen is a bit like a page, and you start writing the page from the top to the bottom instead of from bottom to top. The other way to think about vectors is a little bit as if they were like arrows from one point to another. So if we have these 2 points, then this would be the x difference and this would be the y difference between them. And that would make a xy vector. And so, well, let's look here what we have here. So here I have a little demo, and I have 2 vectors. The target and the start, which is both of these are set to 0 at the beginning. We're not doing anything in process. Process, this is things that happens every frame. We'll be using Godot, but this is applicable to Unity, Unreal Engine, a lot of other programming languages. What's happening is that we have a reset button, and this reset button is setting the start vector to the player's position. The player is this little cat. And the target, it's set to a random vector, and then the heart's position is set to the target. And so as you can see, every time I press reset, the heart changes to its position to a random position. And this really is that I'm choosing my getViewportRect.size. That is telling me how big my viewport is, how big the screen is. So for example, maybe this is between 0 and 100. And then what I'm doing is I'm multiplying by a random number between 0 and 1. And this is what my randf is doing. It's going to give me a random number between 0 and 1. And so when I multiply them together, I get a random number between 0 and 100, which is how we get our random vectors. And so what I would like to do is to move my player towards the heart. And so what I can do is I have my little player, I have my heart, and so this is my target and this is my start position. But really what we care about is the player's position. And so we want to find what this vector is, and then we want to move alongside this vector. So what we're going to do is we're going to, well, calculate that. So that would be the target minus the player position. This is because if I have my player position and I add the target minus the player position, I get the target. So if I start with the player and I add this vector, which is going to be this blue vector, I will reach my target. As you can see, yes, player position cancels out, and so we're left with the target. So this is precisely the vector that we want. So that's going to be the difference is going to be a vector, and it's going to be the target minus the player's position. So for example, now if I just say that player position, I increase it by the difference. Let's see what I have. Oh, I need to set it to running. And as you can see, as soon as it sets to running and the process begins, the player instantly teleports to the location of the heart. And that's because I'm adding the final thing, right? So what I'm going to do instead is I want to find a way to move slowly towards it. What we will need to do is find the direction of the vector. So a vector, if you think about it as an arrow, it will have two components. One of them is like the direction it's going in, so it will be like this direction, and the other one would be the length. And one way to think about direction is by using angles. So this would be like the angle theta, and this is something we could get from our vector. But another thing is what are called normal vectors. So a normal vector is a vector of length 1. And so if we normalize our vector, we will get a vector that is pointing in the right direction, but is only of length 1. So that's very useful for using speed. So let's do that. So this is something we can do directly. I can write var the normal vector, which is going to be a vector 2. And that's going to be my difference normalized. And so now if I do this, it's going to start moving in that direction, right? And it's moving by 1 pixel every frame in this case, because it's a vector of length 1. The issue now is that this is moving 1 pixel every frame, and we want to be able to control the speed. But we also want the speed to be independent of the frame rate. So if it's going at 30 FPS or at 60 FPS, we still want to go at the same speed. And so that's why we're going to multiply by delta, which is how much time has passed since the previous frame. And then we're going to multiply by our speed, which is going to be a constant. So let's set it to just 100. So we reset it and set it to run it, and it's going to be moving. And no matter where the target is, it will always move at the same speed. And so if we increase the speed, it's going to be going faster. Okay. And so that is how we can use normal vectors. That is quite useful. Another example of how we can use normal vectors is, you might have noticed this little cat is actually looking in the direction that it's moving, right? So the question is, how does this work? If we look at this code, it is once again using normalize. So what is it going? It's checking what the position minus the previous position is, and that's telling it what speed it is moving in. But this speed is going to be very small. It's moving like 1 pixel every frame, for example, or it might be like moving a lot. And so what it's doing, it's going to say, well, just normalize that into something we can work with that is of standard length. And then I am doing something which is something we don't usually do with vectors, which is rounding it and transforming it into an integer vector. And so usually normal vectors lie in the unit circle. So this is the circle of all the vectors of length 1, of radius 1. And what I'm doing essentially is just rounding it so that we get a little grid. And so this grid is going to be like 0, 0. Sorry, it's going to be -1, -1, 0, minus 1. This is going to be 1 minus 1. This central one is going to be 0, 0, and so on. And so now that I have this vector that is now made of integers, I can use the frame coordinates of this little image, but the frame coordinates are a little bit different. The frame coordinates now have 0, 0 being this one is 0, 1, this one is 1, 1, and this is 2, 2. And so what I'm going to do is just transform from these to these by just adding 1, 1. Okay, so we've just seen a couple of different uses for normalizing vectors. Normalizing vectors is something you will want to do quite often. It's telling you basically, so if you have a vector v, you can think about it as a direction and a length. Length is very important. It's how we would be able to check if we have reached the target, for example, or how we check how far things are from each other. But often we also want to be interested in the direction. And this direction, we can think of it as an angle, or we can think of it as a unit vector, or a like normalized vector.